Hello, students. Today we are continuing our work with trigonometry. There are three trig functions, basic trig functions that we're talking about. We talked about tangent. These are the buttons on your calculator. We talked about sine. And today we're going to talk about cosine. So the key to understanding trigonometry is to really focus on that angle and understand that if you have a similar triangle with the same angle, it's not going to change the relationship. So in this special right triangle, I'm going to say that the hypotenuse is 6. And if I'm wondering how long this side is, because I know it's a special right triangle, I actually know the ratio of x to 6. I know the relationship between this adjacent side and this hypotenuse. Okay, because remember, in a special right triangle, in the special 30, 60, 90 triangle, it's half of an equilateral. So if this is 60 at the top, and this is 60 over here, this side is 6, this side is 6, and this entire side is 6. So how much is this? It's half. So we have a relationship in a 30, 60, 90 right triangle. The ratio between this adjacent side and this hypotenuse is a half. Okay, because we know that x is 3. If I create another right triangle, also with a 30-degree angle at the corner, but let's say I extend the hypotenuse a little bit. If I'm going to create a similar right triangle, I'm going to extend this side also. Okay, this angle down here is still 60 degrees. I didn't change the size of the angle. But now instead of being 6 long, this is more like 8 long. And x is not going to be 3 anymore. It's going to get longer. X is going to be how much? If I increase the size of the triangle, it's going to be similar. It's going to be 4. Okay, but the ratio stays 1/2 because this angle didn't change. I can do the same thing. I can make a really big special right triangle. Maybe, oh wow, should we call that 12? Sure. Okay, and then we drop the perpendicular. So we still have a 60-degree angle here. Still 60 degrees. This side, I'm going to say it's actually 12 long now. It's almost twice the size of the original. So this is going to be how much? Yeah, it's going to be 6 because half of 12 is 6. And our proportion, our relationship is that if we have a 60-degree angle, the ratio says that this side is going to be half of this side. Okay, so what we know is we know that the sine of a 60-degree angle, oops, I lied. We're doing cosine today, my goodness. Cosine of a 60-degree angle is 1/2. Okay, go look, type it into Desmos, use your calculator, see what it says for the cosine of a 60-degree angle. And this is one that's an exact value, right? The cosine of a 60-degree angle is exactly 1/2. There aren't too many exact values on the table, but this is one of them. So now let's look if we know that, if that's our anchor, what if I change the angle here? So what if I increase this angle instead of being 60 degrees? What if I open up that angle? I'm going to keep this 6 long and I'm going to swing this open a little bit more. Okay, so I'm going to say that those are congruent. And it was 3, but if I drop this perpendicular, it's not going to be 3 anymore. Like for this new little triangle that I drew, if I change the angle, it's not 60 anymore. Let's say it's 75. Just kind of made that up. I know it's bigger than 60 because I opened the angle up a little bit more. What's that do to the relationship between the adjacent side and the hypotenuse? It changes it. So if you look on a table for the cosine of 75-degree angle, and we know that's going to be the relationship between x and 6, is it going to be more than half or less than half? If it was 3 out of 6, it would be a half, but this side got smaller, right? So this is going to be less than a half. I'm not entirely sure what it is. I can look at a table, but I know that if the cosine of the 75-degree angle, 75 is more than 60, so that relationship is going to be less than a half. Okay, we can go look at the table. Maybe I'll type it in Desmos this time. Okay, and I can do the cosine of a 75-degree angle. Oh, it's almost a quarter, 0.2588. So 0.2588. Okay, that's definitely less than a half. So if I wanted to find out what x was, I could multiply that by 6, and that could tell me. Okay, let's try the other way. What if I make the 60-degree angle smaller? So here's my 6, and I'm gonna swing this down. And maybe we'll go to there. Okay, and then if I drop, if I drop the perpendicular, again, I'm gonna say that this was 6, this is still 6. But what's changing is this angle. It's not 60 anymore, we'll call it 40. Okay. All right, it looks bigger than 40, but we'll pretend. Okay, and then this is x. Okay, so what's going to be the cosine of a 40-degree angle? Is it going to be more than half or less than half? Are these side lengths more equal to each other? Or like, does this look like half of this anymore? No. So the cosine of the adjacent side over the hypotenuse, in this case, is going to be bigger than a half. Okay, and it's going to get, well, they're never going to be the same because the hypotenuse is always the longest side, but they're closer together. Again, if I look at cosine of 40, 0.866. Oops, that's the 30, 40. So 0.766. 0.766. That's going to be, when I change the angle, it's going to change the ratio of the adjacent side to the hypotenuse side. So that's what cosine is. Cosine is the relation. If this is the angle we're interested in, here's the opposite side through the triangle. Here's the adjacent side next to the acute angle that we're talking about, and here's the hypotenuse. So we know the cosine is the ratio of the adjacent side to the hypotenuse. This is the way that I want you to write it. The cosine of an angle is its opposite side, adjacent side, shiitake mushrooms. All right, it's adjacent side over the length of the hypotenuse. Let's do a practice problem. So what's the cosine of angle H? Here's angle H. Here's the opposite side from angle H. Here is the hypotenuse. How do I know that one's the hypotenuse? Because it's across from the right angle. And this side is called the adjacent side. I would like you to write those out completely, the whole word. And then we're going to write that the cosine is what we're trying to find. And the definition of cosine is that it's the adjacent side length divided by the hypotenuse side length. So for this one, I'm going to do the cosine of angle H is the adjacent is 9 and the hypotenuse is 15. Okay, I can simplify that. 9 and 15 both have 3. 9 is 3 times 3 and 15 is 3 times 5. So if I simplify that fraction, I get 3 over 5. That is a good answer for this problem. What do we know about the size of this angle? Bonus. Is it more than half or less than half? 3/5 more than half? Yeah. So what does that mean about the angle? This is a little, you got to think this through a little bit. So this answer is more than a half. This is 6/10 is bigger than 5/10. So let's look back here. Aha, this one's bigger than a half, which means the angle is less than 60 degrees. Okay. Angle H, the measure of angle H is less than 60 degrees. They're closer together, so they're so the angle is smaller. Let's try another one. So we can move the angle that we're interested in, the reference angle. Now I'm looking at angle F and I want to find cosine. Now 9 is the opposite side because it's opposite through the triangle. The hypotenuse is still 15. And the adjacent side now is 12 because I moved which angle I was talking about. And the cosine of an angle is its adjacent side divided by its hypotenuse side length. It's the ratio of the adjacent to the hypotenuse. And the cosine of angle, well, the cosine of angle F, the adjacent side is 12 and the hypotenuse is 15. Okay, there's a 3 inside of both of those, so I can also simplify that. This is 3 times 4, this is 3 times 5. So this is 4 over 5. Now, how does that compare to 60 degrees? Okay, angle F is also less than 60 degrees. In class, we talked about remembering the relationship here. Okay, it happens to be this 9 is less than this 12. If they were equal, it would be a 45-degree angle, but they're not. So not only is it less than 60, I also know it's less than 45. So it's interesting to think about if we know the side length, we can kind of tell something about the angles as well. So this would be the answer to this problem. If I just asked you for the cosine, you could write it as a fraction or you could write it as a decimal. Here is the trig table. I like this one. It came from an old textbook I used to have. I made copies for all my students. This is one of my favorite. It just shows everything. I like it. So why is it called cosine? That's what I'm going to play with for a minute. So I want you to look at this table and want to find the sine of a 30-degree angle. And it's right there. I know this is small, so squint your eyes and look closely. Here's the angle measure and here's what the sine is. That was an exact value. We also learn right now that the cosine, here's cosine of a 60-degree angle is also an exact value. So we know the sine of a 30-degree angle was 0.5. We also know the cosine of a 60-degree angle is also exactly 1/2. Are there any other places where the sine and the cosine are the same? Someone in class looked and said, hey, Miss Bliss, look at 45 degrees. What's the sine of a 45-degree angle? 0.70171. What's the cosine of a 45-degree angle? Interesting. Is that the only place where the sine and the cosine are the same? Let's choose another number. I forget which one we did in class. Maybe 20. Let's do the sine of a 20-degree angle. Can you find a matching cosine value? Look carefully in the table. If we look in the cosine row, where are we going to see 0.3420? So they match right here. Where is the matching 0.3420? Well, in the sine row, as the angle gets bigger than 60, these numbers are getting smaller. Hey, I found it. It's right here. Okay, so what cosine has the matching? What angle has the matching cosine number? Good. So why is it called cosine? What's the relationship here? So it's related to sine, right? But what's the co mean? And how are you going to know? Like if I say a 40-degree angle, how are we going to know which one matches for the, if I say sine of a 40, where am I going to find the cosine that matches? Well, one way to think about it is, what is 30 plus 60? 90. What's 45 plus 45? 90. What is 20 plus 70? 90. Okay, so we have two angles that add up to 90, right? Does anyone remember the math word for angles that add up to 90? Starts with a CO and it's not congruent. Complementary. So why is it called cosine? These angles are complementary. So the sine of a 30-degree angle is the same as the cosine of a 60-degree. 30 and 60 are complementary angles. 45 and 45 are complementary. They add up to 90. 20 and 70 are complementary angles. So why is it called cosine? Because it's the complement of sine. It's called cosine because it's the complementary angle of the sine. And we can look at it one other way. So we said here's angle F. What is the sine of angle F? The sine of angle F is opposite over hypotenuse is 9/15. Now, what if I change my reference angle? What if I don't use angle F? What if I use angle H? What is the cosine of angle H? Well, angle H, now this is the adjacent side, and this is the hypotenuse, so it's also 9/15. How are angle F and angle H related? How many angles inside a triangle? 180. How much is in the corner? 90. How much do these two angles add up to? 90. So angle F and angle H are both acute and they add up to 90. They are complementary angles. So the sine has the same value as the cosine of the complement. Okay, I'm going to write that. Angle F and angle H are complementary angles. Angle F and angle H are complementary angles. Okay, so this is kind of interesting. Do we need cosine? Good question. All right, let's do a math problem. I want to solve for x. This is the angle that I'm given. These should be getting a little bit easier. This is the opposite side over here. This is the hypotenuse side over here. I want you to write it out, the entire word still. Maybe next week we will start to abbreviate. There's the adjacent side. Okay, now I'm doing cosine today, so I'm going to be using the adjacent side over the hypotenuse side. So the cosine of any angle is defined as any acute angle in a right triangle is going to be the adjacent side length divided by the hypotenuse side length. In this problem, the cosine of a 73-degree angle is going to be x over 6. I'm going to multiply both sides by 6. This is the best way to show your work. Okay, then if you want, you can type this into a calculator. If you don't have a calculator or a phone or a computer, you can go look on a table. That's what they had to do back in the day. They made tables of values. I'm going to look at the table because I'm old school. So I'm going to look for cosine of 73. And here's angle 73. And here's cosine 0.2924. So I'm going to do 6 times 0.2924. Okay, that makes sense because 73 degrees is bigger than a 60 degrees. So this is going to be less than a half. Okay, now I'm going to be lazy and I'm going to type 6 cosine 73 into the calculator. 6 times the cosine, you got to press the cosine button. And it's 73 degrees. Make sure it's on degrees. It is 1.754. 1.754. Is that reasonable? It had to be less than 3, right? So yeah, this is 2, well, maybe 2-ish. I think it's reasonable. All right, sweet. Oh, this one looks like fun. JC anchors a retractable leash to the dog collar. I like how they put the dog bowl so it doesn't seem like it's inhumane. Leash is fully extended, the angle of the leash and the tree is 84 degrees. All right, so fake math problem, right? I'm gonna draw the triangle here. No one would ever do this. If you tie your dog out, you're just gonna see how long it goes and you're not gonna, also tying dogs in the yard is not very humane. Okay, so this is, notice the first thing I did is I made my right triangle. And this is not going to be 4 feet because the dog is 2 feet up. So this is actually going to be 2 feet. So I'm engaging with the problem. Basically, I'm redrawing my triangle, getting rid of the dog, just turning this into a problem like any other problem. We got 84 feet here, and that's all we need. Okay. This is asking about when the leash is fully extended. Oh, if the neighbor's dog yard is 18 feet away from the tree, can JC's dog get into the neighbor's yard? So what we want to know is this. We want to know if this dog runs around the tree towards the neighbor's yard, is the leash going to be long enough? This is a little messy. Okay, so let's find out. If so, how far into the yard can the dog go around to the nearest foot? So we want to solve for x. This is an 84-degree angle. So we're going to do the cosine of any angle is the adjacent over the hypotenuse. This one is a little bit harder because it has the hypotenuse in the denominator. So this is the cosine of an 84-degree angle is going to be 2 over x. For this, I'm going to multiply both sides by x. Okay, that's going to make my x be no longer in the denominator. Then I want to find x, so I'm going to divide both sides by this weird decimal, which happens to be the cosine of 84. And I ran out of room, so I'm going to go over here. I'm going to finish this problem. This is going to be x equals 2 divided by the cosine of 84. And I don't want to mess around, so I'm going to put that into Desmos. Delete all that. I'm going to do 2 divided by cosine of an 84-degree angle. And I get 19.13. Haha, what does that mean? 19.13. Okay, that means this leash is 19.1 feet long. And if the neighbor's yard is 18 feet, then the dog can go into the neighbor's yard. How much? 1.1 foot into the neighbor's yard. So that's interesting. Okay, fun times. Here's another one. This is the same idea where you have the opposite side is over here. The hypotenuse side is here, and these are the harder ones. We'll spend more time on these again later this week. And this is the adjacent side. And we know the cosine of any angle is its adjacent side divided by its hypotenuse. And the cosine of a 59-degree angle. Well, come on. Do I really have to do this? 59 is really close to what, you guys? 59 is darn close to 60. So I think I know that what this answer is going to be close to. Do you guys know what it's going to be close to? We'll do it the long way and then see if I'm right. 60 degrees. Short leg, long leg. All right. This is the cosine of a 59-degree angle. That's going to equal 34. Notice I'm multiplying both sides by x. Okay, now I'm going to divide both sides by the cosine of a 59-degree angle. This is the algebra. This goes to 1. A weird decimal divided by the same weird decimal is just 1. Okay, and so we have x equals, all right, cosine of 59, let's see what that is. Should we go to the table? Let's look at the table. Okay, 60-degree angle is right here. Cosine of a 60-degree angle is exactly 0.5. What's the cosine of a 59-degree angle? 0.515. So if you use your brain, you don't have to 0.515. You can get a really good idea of the answer without actually doing the work. I want to show you one more time the cosine of a 60-degree angle is exactly 0.5. The cosine of a 59-degree angle, a little bit more, because that angle got a little bit, the angle got a little bit closer, which means that opposite leg got a little longer. Okay, and what were we supposed to multiply that by? We were supposed to divide that by something. 34 divided by that. 34 divided by cosine 59. 66, whatever it is. Is it reasonable? What did I think it was? What's 34 times 2? 34 times 2. 74. Wow, that 1 degree actually changed a lot. Did I do it right? 34 divided by 0.501. Let me just check. 34 divided by, what if I put 60 here? Oh, because I can't do math. All right. Yes. 68 is what I thought it was going to be. And 66 is what it actually is. Okay, good times. Because 34 times 2 is 68. I was pretending like it was something else. All right. That's it. Practice. Cosine. Adjacent over hypotenuse. Be good. Work hard. Keep learning.